Okay, so in this question here, a boy throws a pebble from the top of a cliff, 70.2 meters high, so he's at the top of the cliff there, there's the height of the cliff, with an initial velocity of 14.7 meters per second, and it says upwards, isn't it? Vertically upwards. So he throws it upwards, taken upwards positive as such, and then of course you know then as gravity acts downwards, your acceleration is going to be actually then opposing a positive direction. It's going to be minus 9.8, right? And don't forget then our initial speed is 14.7, okay, meters per second. And then we've got, to calculate the speed, it says when t is 2, okay? So when t is 2, we want to find the speed. So quite simply, we can use v equals u plus at, yeah? So v will equal u, which is 14.7, plus a, but of course a is minus 9.8, so it'll be minus 9.8 times 2. So if I work that out in my calculator, I get out minus 4.9 meters per second. Now don't worry that it's a minus. Remember, velocity describes direction as well. So what's basically happening is, at 2 seconds, that pebble is already falling. Okay, so it's thrown upwards, but by the time t gets to 2, it's already reached its maximum height, and now it's on its way down. Okay, hence why we've got a negative velocity to show it's going in the opposite direction to positive. Okay, but when you say it's speed, you need to say, look, speed is 4.9 meters per second. Okay, you need to obviously take the positive then. Part B then says calculate the speed when the pebble, speed of the pebble when it hits the ground at the foot of the cliff. So yeah, it'll go up on it and then it'll come down and it'll hit the ground. It's important to note when it hits that ground, right, that it's going at some speed, all right? So we want to work out what v will be, okay? Now, of course, acceleration will still be minus 9.8, right? Because, of course, we're taking upwards as positive. Remember, the direction it initially goes in, that's what we're taking as positive. So coming on its way down then, it doesn't matter the fact it's coming down, we're still taking upwards as positive, right? So A is minus 9.8. U, of course, is still 14.7, okay? But, of course, we also know what S is, the displacement. Now, when it hits the ground, it's going to be here, right? And that means it's moved 70.2 meters away from its starting position, okay? But remember, that's the starting position, so this is where S is 0. Remember, though, upwards is positive, so it goes upwards, that's positive displacement. When it falls again then, obviously it'll have 0 displacement when it gets back to its starting point, but as it keeps going down then, it'll have negative displacement, because this is a negative. If upwards is positive, downwards is negative. So S will be minus 70.2. Okay, it's important that you do put minus there, 70.2. And then, if we use, in this case, v squared equals u squared plus 2as, we can work out what v is going to be. Okay, so u squared, that'll be 14.7 squared, plus 2 times a, which is minus 9.8, times s, which is minus 70.2. So if I type that into my calculator in one go, I will get 1592.01, and then to get its speed then, of course, I just need to square root that answer, and I get 39.9 meters per second. Okay, so that's its speed there, all right, when it hits the ground. Part C then, it says find for how long is the pebble at least 3.969 meters above the top of the cliff. Okay, so above the top of the cliff, when it's sort of rising upwards, how long is it at least 3.969? Now the way to do this is, right, is just to first of all imagine where 3.969 will be. So if I draw a line, right, and that height there will be 3.969. 3.969. So basically that pebble will be thrown upwards, okay, and it will hit the height of 3.969 there, obviously, but it'll keep rising, won't it? Okay, it'll keep rising, okay, and then obviously it'll reach its max height, and then it'll start to fall, okay, so it'll start to fall. Obviously it's in a straight vertical line, so it would fall in the same line, but just for our purposes to understand what's going on here, if it goes upwards, reaches the max height, then it'll go downwards, yeah? Now there's 2 times when it will be at 3.969. So it'll be that first time there on its ascendancy, and then as it reaches its max height, then it starts to fall, and when it falls then in its descendancy, it will be at 3.969 again. Now if I can work out those 2 times when it's at 3.969, if I can work out those 2 times, the first time when it's on its way up, and then the second time when it's on its way down, if I can get those 2 times, I can then work out how long it's above 3.969 meters, and we'll get our answer. So, to work out those 2 times, what we do is, right, first of all, obviously put our conditions down. U is 14.7, A is minus 9.8, but I'm interested in when the displacement is 3.969, okay, and there'll be 2 times for this, won't there? There will be 2 times on this ascendancy and on this descendancy. So what are those 2 times? Well, if we use S equals UT plus half AT squared, okay, so S is 3.969, U is 14.7, plus half, A is minus 9.8, and then T squared, okay, so we'll get that. Now, what I'll do next is simplify this, so I'll have 3.969 equals 14.7T minus 4.9T squared. Get it all onto one side. Okay, so it's a quadratic obviously, and then we can solve this, and I'm going to solve it using the formula method, so it'll be minus b minus that, plus or minus square root b squared minus 4 times a, which is 4.9, times c, which is 3.969, all over 2a, and a is 4.9, so it'll be 2 times 4.9. So a lot of calculations there, but just take our time. That becomes positive 14.7, plus or minus. If I work out that root there, I get in that root 138.2976 all over 9.8. So then I can get the 2 times. So if I take the plus time first, I get 2.7 out. And if I take the minus time, I get 0.3. So now it's quite clear to me. The first time is going to be 0.3. So on this ascendancy, when it's on its way up, the time will be 0.3. And then it goes to the top and then falls down. And the second time will be 3.969, will be 2.7. So in between, it's above, isn't it? So it's above 3.969. So if I take them away, we can see then it'll be above, or it'll be at least 3.969 for 2.4 seconds. Okay? And we are done.